can't we watch a movie? Your other eighth grade, your eighth grade.
We will. You can watch it next week when you're reviewing. Oh, just kidding. Okay, here we go. All right, we're set now. Thank you for your patience. Here we go. This is the last lesson. So you do have a test coming up. It's on the calendar. All right, here we go. So we are solving more trig equations again, but today we might have to do a little substitution with some formulas in order to clean them up. A couple of things we want to look for. We don't want to mix and match. We want to have only one type of trig function. So you don't want to have sines and cosines necessarily. You can do it sometimes, but so those are the kinds of substitutions we're going to look for. And then, of course, if you see a double angle, we want to expand that somehow. So you want to pay attention to see if you have any double angles in your equation and do some substitutions to get rid of other things as well. So example 1, we're going to solve the following equations on the interval from 0 to 2 pi, including 0, not including 2 pi. So big long equation here. What is the thing that's standing out to you? Okay, so in general, whenever we have some higher order equation, we're going to push everything to one side. Is there anything in this formula, in this equation, that's standing out that's kind of weird? The 2, yeah, right here is the double angle. We cannot have that. And so we are going to do a little substitution on that double angle so that it is not. We cannot solve with that double angle worked in there. Now, you'll notice everything else in this equation is cosine. So when I go up and I'm going to do a little substitution for cosine 2 theta, I don't want to choose this one because then I'm mixing cosines and sines. I don't want to choose this one for the same reason now I'm putting a sign in. So I'm going to substitute with 2 cosine squared theta minus 1. So in place of my cosine 2 theta, I'm going to substitute in my 2 cosine squared theta minus 1. So you'll notice that 3 is still multiplied out in front. And I'm just going to rewrite everything. Minus 8 cosine theta plus 5 is equal to negative 8 cosine theta plus 8. What do you want to do next? We will, before I do that, distribute. Yeah, I need to multiply my 3 in there. So that's going to be 3 times 2 is 6 cosine squared theta, and 3 times negative 1 is negative 3. Minus 8 cosine theta plus 5 is equal to negative 8 cosine theta plus 8. All right, so now, Emily, what did you say? Make it equal to 0. So we're going to push everything to one side. So I'm going to go ahead and add 8 cosines of theta and add 8 cosines of theta. And what happens to those? They cancel out. That's magical. And then I also am going to go ahead and subtract 8 and subtract 8 so that everything is on one side. So that I get it set equal to 0. So I have 6 cosine squared theta. And then negative 3 plus 5 is 2 minus 8 is negative 6, and we're all set equal to 0. We could factor out a 6. Can I just use the square root method though? Yeah? So I'm going to, well, we're already here. I might as well. I'll just factor out the 6. If I factor out the 6, that's going to leave behind cosine squared minus 1. Very good. Yeah, well, 6 does not equal 0 on Earth. And we can set cosine squared. We could double bubble this as well, as you said. But I can go ahead and just solve that because it's, I can just take square roots. So I'm going to add the 1 to the other side. So cosine squared equals 1. And then how do I get rid of the squared? Square root. We don't care about it. You're with us now? Okay, good. I just will take a pause. All right. We can take a square root, so we get cosine of theta equals plus or minus 1. And this is where we hit up our unit circle and say, hey, where does cosine have a value of 1 or negative 1? 0 and pi. Yeah, so theta equals 0 and pi for our cosine values of 1 and negative 1. Okay. Basically, yeah, it's just one new step that you might need to substitute. Yeah, yeah. All right, letter B. What's the problem with equation B here? Sine and cosine, it's all mixed up. And so I need to substitute. I've got a bunch of cosines. Sine squared is something I can substitute in place of. So I want to find another thing that says sine squared. So I'm looking back at my identities here. So here's sine squared. What can I replace sine squared with?
1 minus cosine squared.
Yeah, how did you get that, Will? Subtract cosine squared. Move that cosine squared over so the sine is by itself. So yeah, so there's a negative 4 in front. So I'm replacing the sine squared with 1 minus cosine squared theta. Minus cosine theta minus 3 equals negative cosine theta minus 5. All right, what do we do next? Distribute. Good plan. Negative 4 times 1 is negative 4. Negative 4 times negative is positive for cosine squared theta minus cosine theta minus 3 equals negative cosine theta minus 5. Move it all over to one side. What happens to the minus cosines? They're going to cancel each other out. So I just need to add the 5 and move the 4, yeah. So I have 4 cosine squared theta. Negative 4 and negative 3 is negative 7 plus 5, negative 2. Set equal to 0. How are we going to solve this one? Yeah. I'm going to add the 2 and then divide by 4. So I get cosine squared equals 2 over 4, which is, okay, I'm just going to write that 1/2. And then square root, don't forget, plus or minus. So I have cosine of theta equals plus or minus. Now this is the square root of 1 over the square root of 2. So the square root of 1 is 1 over radical 2, and what do we have to do with that? Rationalize, good. I just like to make sure, because we haven't done that in a while. So that becomes radical 2 over 2 once you rationalize. And so now we go hit up our unit circle. Where does cosine have a value of radical 2 over 2, positive or negative? All the 4s, all the 45s. So all the pi over 4s. 1 pi over 4. Whoops, that's not a 4. 1 pi over 4. 3 pi over 4. 5 pi over 4 and 7 pi over 4. Beautiful. One more. Last one with lots of extra work, paper to do all the rest of your work for your homework. All right, what's the problem with this problem? Yeah, we're mixing them up. So we've got, yeah. Oh, yeah, so cosecant, let's see, cot plus 1 equals cosecant squared. Okay, so cotangent squared. Okay, so there it is. So cot plus 1 equals cosy. Do you remember that? Cot plus 1 is cosy. All right. So we get to replace cosecant squared with what it's equal to, which is cot plus 1. All right. So I got 3 out in front, minus 9 cotangent theta minus 6 equals negative 9 cotangent theta plus 6. Don't you feel like a pro when you're solving an equation that's this long? Like, does it make you feel smarter? Are you with me so far? I just recopied it. Yeah? Okay. Like, I hope you're not confused right now. What do you want to do next? Distribute. Okay. So 3 cotangent squared theta plus 3 minus 9 cotangent theta minus 6. These are such formulaic problems. Okay. All right, what do you notice?
Equals 0, but everything cancels.
Oh, yeah, if I add the 9 cotangent, those cancel out. If I minus, oh, that doesn't cancel out. Minus 6, that doesn't cancel out. Yeah, we get a 12 there. So, let's see. So we have 3 cotangent squared theta. We have a negative 12 plus 3, which would be negative 9, equals 0. Add 9. And then divide by 3. So that gives us 3. Okay, so cotangent squared theta equals 3. And square root both sides. It was a minus sign, so I added it to the other side.
The 12 minus 3.
The 2 6s, negative 12. Got it? Okay. All right, so I have cotangent theta equals plus or minus radical 3, but what do I need to do when I have a reciprocal function? Flip it. So I want to flip both sides, take the reciprocal of both sides. The reciprocal of cotangent is tangent. And when I flip this, I get plus or minus 1 over radical 3. I'm just going to leave it like that because that's a little easier on the unit circle for me. So I don't have these memorized. My ordered pair at pi over 6 is long leg up the little half. And here it's 1/2 up a long leg. And I think it's this one. So tangent would be 1/2 over radical 3 over 2. That's the winner, right? Okay. So right here at pi over 6, I'm going to get my, because the 2's cancel, 1 over radical 3. All those, I call these the bow tie. The bow ties, do you see the bow tie? Yeah, I call these the bow tie angles because it sort of makes a little bow tie like that. See it? Okay. So that's 1 pi over 6. Good. And 11 pi over 6. Those are the bow tie angles. The other one, all the over 3s, those are, I call the butterflies. I do. Because it's like the wings on butterflies when you, yeah, draw. Okay, so bow ties. Do you guys have questions for me? Oh, 14 minutes. I was off by 2 minutes. So now you have a work day.